Lesson 7 of geotrig, day 2. We're going to continue with our valid and invalid arguments. Let's just recap really quickly. These are arguments that have two premises and then a conclusion. So the first premise, remember, sets up a group that has a quality. To be a valid argument, it's going to place in premise number 2 someone into the group. So therefore the conclusion will be that person has the quality. That would be a valid argument. Anything from that is not true. So therefore invalid. Okay? So we did the first 3 on here. We're now starting on number 7. Number 7 says, all normal dogs have 4 legs. That dog has 4 legs. Therefore, that dog is a normal dog.
Invalid.
Invalid.
It's invalid what?
Because he could have 4 legs but no ears.
Okay, he could have 4 legs but no ears. Okay, that would not be normal, I guess we'd say, right? There is something else that could be wrong with the dog that would make it not normal. Just because he has 4 legs. Now, think of this. I thought of this example back with 6 hour. We've talked about functions before. Maybe not us, but as a class in Algebra 1 or Algebra 2. Do you guys remember what a function is? Every output has exactly one input. You guys remember that?
Yeah.
It's a very special thing. It's a rule, right, that is special. Do you guys remember a mathematical relation or relationship is? A relationship is just a connection, right? Between an input and a output. Like an ordered pair. X comma Y. Input, output. There's a relationship. I put 2 in, I get 5 out. There's a relation. Do you guys remember the fact that you can have things like sets of points? You can have equations, but those equations don't necessarily mean that it's a function. But here's the thing. A function will automatically guarantee that there's a connection, which means that there is a relation. One does not imply the other. Like, one way does not imply the reverse way. A function is always a relation. Do you guys agree with this?
Yes, sir.
But is a relation always a function? No. So you can't say it both ways, right? So it's kind of like that. So if I say, hey, it's a relation, therefore it must be a function. That's not enough information, right? It's not a valid argument. You're not going to win with that, are you?
Most likely not.
Okay. So that's what we're trying to set up here. So this is invalid. Whoops. Invalid. Next up. All boys are good in this world.
No.
Okay, doesn't have to be true, right?
There's definitely two.
Boys rock.
That child is a good child.
No.
Therefore, that child is a boy.
Invalid.
It's invalid again, right? Because their child could be a girl and still be good. It didn't say anything about anybody else being good. So you could be good and
You could be good and not be a boy or
be a boy. Or be a girl.
Can't assume one.
Okay. Next. So that's invalid. What about Henny Penny? All chickens have 3 legs, of course, right?
Yeah.
Henny Penny is a chicken. Therefore, Henny Penny has 3 legs.
That is valid.
Valid.
It's a valid statement.
That's a valid statement.
Here's the right picture.
Guys, why? Chickens have 3 legs. So if you're a chicken, you have 3 legs.
Yes.
Henny Penny is a chicken. So now puts Henny Penny as someone in the group. So therefore, Henny Penny has 3 legs. Henny Penny has the quality of the group. Is that true?
That is true.
That's true.
How did you come up with that?
I'm not sure if it came out of the book or something. I don't know. Does that make sense, guys, with our arguments here? Are you guys starting to see that sometimes they're true, sometimes they're false? Sometimes they're valid, sometimes they're invalid. It doesn't have to make sense in the real world. Next one. Here's the information. So now what we're going to talk about is when we start to change those premises around. There's something that we can call the converse. So if I'm looking at this, if P implies Q, the converse would be Q implies P. So, like we have on the side of there, if a rabbit, then fast. That makes sense, right? So, okay, we're breaking it down to the smallest pieces. So if you are a rabbit, then you are fast. Or if it is a rabbit, then it is fast. Could you guys safely make that assumption?
Yes.
Okay. We can have a converse, guys. The converse means the opposite. If it is fast, then it is a rabbit. Does that necessarily have to be true?
No,
Okay.
it can be, but it's
It can be, but it
not.
also may not be.
Yeah.
Because just because it's fast doesn't mean it has to be a rabbit. There are many other fast items or animals or things, right? So, look at the example they have written there. If it is raining, then the grass is wet. That is the first initial statement or premise. The converse of that would be, if the grass is wet, then it is raining. That could be true,
But it's not always.
but I could also got my sprinkler out and turned it on, right? Or the dew in the morning. Okay? So, as in the example, a proposition may be true, but have a false converse as well. So the rabbits. Just because it's fast doesn't mean it's a rabbit, but it could also be true. So, sometimes the converse is helpful. Sometimes it's not helpful. We got to learn something else here, and that is called the contrapositive. I think this one is the more helpful. The contrapositive, guys, is the stated Q to P, right? So that's like the converse, but it has those little squiggly lines in front of it. That squiggly line, guys, is just the word not or opposite. So, if P implies Q, then obviously not Q. If not Q, then not P. Here. Does this say, okay, read the statement. If it's a rabbit, then it's fast. That was the proposition.
Right.
The contrapositive is, if it's not fast, then it's not a rabbit. Does that make sense? Because rabbits are fast. So if it's not fast, rabbits are out. I don't have to worry about rabbits. It's kind of like, it's like when you guys play Guess Who. Does your person wear a hat? No. So therefore, what do you do with everybody who has hats? You take them down, right? So therefore, it's like that. The contrapositive. Now what's doing is it's putting a not on both sides. It's a not not. And a not not is a double negative. Now, you've got to be careful. We're saying not here, so you also have to change it from not. It's more like the opposite, right? So not just as a not, it's an opposite. So the opposite of this and opposite of that. So do you notice from the preposition of P to Q, it's switching Q to P, but also opposites. So it's like opposite, opposite. I don't know if that... It'll help us establish answers for some of our problems. Especially when we talked about, like, is our car on or not, according to if we have gas or not. Should we go back to that problem? Okay, let's skip the if-then statements for now. Let's go back to this guy. Where are we? That one.
Number 6.
So, 6 and 5. The preposition for both of those, the major proposition or premise. A car without gas will not run. I think I just erased that. I can actually go backwards if I want. No gas equals no run, right?
Correct.
So let me just actually erase that part underneath it. So if no gas, it won't run. I can write the contrapositive of that. So if the car runs, it's because I have gas. Now, does the second preposition or premise put me into this first group? I don't have any gas. Doesn't put me here, but wait a minute. It does put me in the original. So sometimes we switch it, sometimes we don't. So in this, number 5, I wouldn't need to go with the contrapositive. But in the second one says my car does not run. Does it put me into the first group here on the regular premise? No. Does it fit into the contrapositive? No. So I can't make any statement about having gas or not gas. So actually, it's just an invalid argument then. Because it doesn't put me into the group to have the quality. Mike. So now we're back to if-then statements. I've been doing some of this with our problems already. As in, I've been changing them from statements of just words like, I'm trying to think back. Let's see. All chickens have 3 legs. We could change that to say something like, if a chicken, then you have 3 legs. What we're doing is we're trying to create a group, or if this, then that. Because then it's really easy to find contrapositives and converses, and really easy to put yourself here, which implies there. So what we got to do is I'm going to have you guys take a list, it's on the next slide, of different phrases, and I want you to create an if-then statement. But here's something really interesting. All definitions can be written as if-then statements, and they work both ways. So this is one of those weird ones where the converse would actually work and be true. As in, look, if an angle has a measure of 90 degrees, then it is a right angle. If an angle is a right angle, then it has a measure of 90 degrees. Isn't that true? It's because that is a definition. Definitions work both ways. So therefore, if it's not a right angle, then it won't measure 90 degrees. I just did the contrapositive. Okay? There's a long list. I want you guys to write if-then statements. Guys, we don't need to do all of these together, but all students like geometry. Okay? False or not?
I actually enjoyed it.
Okay.
I enjoy it more than...
What's the if-then statement that we can draw from this? Angel.
If a student, then they like math.
Not math, but geometry. So, if a student, then they like geometry.
No.
They're basically the same thing.
Okay. Now,
Not really.
if you can, guys, listen. If you can write the if-then statement, so if you're a student, then you like geometry, can you write the contrapositive? If you
you're-
don't,
if you like geometry, you're a student.
no. You gotta flip it and opposite. Say it again.
If you don't like geometry, you're not a student.
There you go. If you don't like geometry, then you are not a student. Because it says all students like geometry. Doesn't that make sense then?
Yes.
So it has to
If
be,
every-
it has to be, like, it has to make sense.
If everybody does something or likes something, and you're part of the group that does not like it, well then you can't be part of that group.
Sorry. Sucks to be you.
What's so funny? I'm sorry. That's not even that appropriate.
Guys, next one. Susie, let's do number 14. Susie eats pizza every Thursday. What kind of if-then statement can I get from Susie eats pizza every Thursday? I think I like it. If it's Thursday, then Susie will eat pizza. What would be the contrapositive?
If Susie doesn't eat pizza, it's not
If Susie doesn't eat pizza, then it's not Thursday. You guys good with if-then statements? Contrapositives?
Yeah, I get it.
Lesson 7, day 2, page 58. 1 through 6, which is all the if-then statements and valid, invalid arguments. 20 and 28. Do a little bit of reviewing. Don't forget how to find the volume of a shape. Don't forget that it's the AOB times height. All right, have a great day.